convex lens and concave lens. You can see here spherical lenses. Uh, Spherical lenses are of two types: convex lens. This type of lens is convex lens, and this type of lens is concave lens. And this convex lens is known as the converging lens, and the concave lens is known as the diverging lens. Okay, and this is thick at the center, thinner at edges. This is thinner at center, thicker at edges. Okay, and after that, I have discussed the principal axis and the optical center. Principal axis and the optical center. So for a convex lens, this is the convex lens, and for this convex lens, the center point of the lens, the center point of the lens is the optical center. Like in case of mirror, we have pole. The center of the mirror is pole. Here in lenses, the center of lens is optical center, and a line which is passing from this optical center and perpendicular to the surface is principal axis. Okay, Azaan, are you getting my voice clearly?
Yes.
Okay. So same is the case for the concave lens. And after that, I have discussed the focus for the focus and the focal length for the convex lens. So you can see here the rays are parallel to this principal. This is the principal axis, and these rays are parallel to the principal axis. Okay. So these rays are parallel, and after the refraction, these rays are meeting at this point, and this point is called as focus. And that is why this convex lens is known as the converging lens, because it converges all the parallel rays coming from infinity. These are the parallel rays. So, and I have given the assignment also. So the first question of the assignment is this. They are saying name the lens which can concentrate sun's rays to a point and burn a hole in a piece of paper. Azaan, can you tell me the name of the lens? Which lens can do this? First, read the question. Okay. So, see here, rays are coming parallel and they are concentrating at a point. Means all the energy of the rays is concentrated at a point. So, they are saying name the lens which can concentrate sun rays to a point. So here convex lens, this convex lens can concentrate the sun rays. These are the parallel rays, and parallel rays are coming from an object which is at infinity, and sun is also at infinity. So we can say convex lens. So this answer of this is convex lens. Second question. They are saying what is a lens. I have told you what is a lens. You can check the notes. And they are saying distinguish between a convex lens and a concave lens. Which of the two is converging lens, convex lens, or concave lens? So lens is made up of transparent glass, okay, having spherical faces. And difference between the convex lens and the concave lens is that convex lens converges the parallel rays, and concave lens we will discuss diverges the parallel rays. and which of the two is converging lens? So concave lens is the converging lens. So this you can do by the notes. They are saying in this question they are saying, give the usual name for the following: a point inside a lens through which the light passes undeviated. Actually, this point is the optical center, and I will discuss this point. Optical center. So when you will take the lens, suppose this is a convex lens, and this point is the optical center, and when a light ray is passing like this, so this light ray will remain undeviated if this light ray is passing from the optical center. We will discuss this. Now, principal focus and the focal length of concave lens. Okay, Azaan, see this. Uh, this is the concave lens. This is the concave lens, and this line is the principal axis, and this is the optical center. This is the optical center, and rays are coming like this. So now you can see here. What will happen? Okay. Rays are coming parallel to this concave lens. Okay. So in case of concave lens, what happens? Rays after reflection, rays after refraction will appear to meet at a point. In actual, these rays will diverge. Okay. So these rays will be like this. Okay, we have done. Okay. So what will happen? All these rays will meet at this point. All these rays will meet at some point. So you can see here, rays are parallel, and after refraction, they are diverging. And when we produce this diverging ray in the backward direction, these rays are just appear to meet at a point, and this point is called as the focus. This point F is called the focus of concave lens. And this lens is known as the diverging lens because parallel rays after refraction diverges. Okay, these rays will go like this. Okay. So this is the focus of, here F is the focus. Here F is the focus of this concave lens, and the distance between this focus and the optical center is the focal length. So you will say OF is the focal length, and focal length I will represent with small f. Okay, so just note it down, Azaan. Just note it down. Here the refraction is taking place. Okay, refraction is taking place, and after the refraction, the rays are diverging like this, and I have just appeared these rays backward, and in backward these all the rays are meeting at a point, and this point is known as the focus. Okay, this point is known as the focus. Just note it down. Just note it down. Okay. Azan, is your internet connection is okay? Yes, sir. Azaan, you have not sent me the solution of math test. Beta, okay, no problem, but please send me. Just copy this. Okay, okay, no problem, Azaan. You can send me. It's fine. Okay, done. Done na? Now after this we will write some note points. Written, Azaan? Yes. Okay. So we will have some note point now. First point is uh, the focal length of the lens depends upon the material of the lens, and the material of the lens means the refractive index of the lens. So you can write focal length depends on the refractive index of material of lens. And the curvature of two surfaces. Curvature of two surfaces. This is first note point. And another point is that if you are having a convex lens, if you are having a convex lens, suppose, and this is the principal axis. This is the principal axis. And the optical center is this. O is the optical center. So in lens, we have two focus. In lens, we have two focus. There is one focus here. There is one focus here. I am representing the second focus. This is first focus and this is second focus. Okay. There are two focus in the lens. And same is the case for the concave lens. You have a concave lens. This is optical center. F dash. So right here F dash and F, and F R. Foci. Foci is the plural of focus. Of length. So the meaning of this is, suppose the parallel rays when coming from this side will meet at this focus, and parallel rays are coming from this side will meet at this focus. So what is the meaning of the principal focus? Principal focus is the focus at which the rays are meeting or appearing to meet. Okay, so suppose the rays are meeting at this focus after refraction, so this will become the principal focus. Okay, so and just add one point in the principal focus and the focal length of convex mirror. Add one point here. A convex lens has real focus. Why the convex lens has the real focus? Because rays here are actually meeting actually. Okay, just note this point. A convex lens has real focus. And add one point here. A concave lens. So can you tell me about the focus of concave lens? Will it have real focus or virtual focus? See here, rays are just not meeting actually. They are just appearing to meet. Can you tell me? Yes, sir. I am saying a concave lens have virtual focus or real focus? Real. And a concave lens? Real. No. This concave lens has virtual focus. See here, because here light rays are in actual, the light rays are diverging. Okay. Light rays are not meeting actually at this point. These light rays are just appearing to meet. So this have the virtual focus. Virtual focus. Please add these 2 points. And please note it down. Then we will discuss the rules for the lenses when the light rays are striking on the lens. Written? No, sir. This is the focal length depends on the refractive index of material. This is written. Okay, very good. So now we will have rules for obtaining which lens is this? So rule number 1 is that if a light ray is parallel to the principal axis, like this, see here, it will pass from the focus. This light ray is parallel to this principal axis, and after refraction from the lens, con convex lens, it will pass from the focus. Second, second is very simple. If a light ray is passing from the optical center, it will not bend. Mean it will go straight. Okay. The light ray is passing from the optical center will not change its path. Third, third is again very simple. I have told you here will be some focus. Here is the focus. And if a ray of light is passing from the focus, suppose the ray of light is like this, is passing from the focus, and this is the focus, suppose. This is the focus. So what will happen if the light ray is passing from the focus after refraction from the lens? It will become parallel to principal axis. So light ray is coming like this, and after refraction from this lens, convex lens, it will become parallel to principal axis. So these are the three rules that we will use in the image formation. In the image formation by the convex lens. And O is the optical center. This O is optical center. Just copy this. These rules are just same as the rules for the concave or convex mirror. Concave mirror we have discussed. Means in mirror what happens when a light ray is parallel to principal axis. When a light ray is parallel to principal axis, after reflection, it will pass from the focus. And here what is happening? A light ray which is parallel to the principal axis, after refraction, it will pass from the focus. Just copy this. Written. Yes, sir. This one also. Yes. So these are the three rules we have to follow in the image formation. So now write the heading formation of image by convex lens. How the image will be formed? How the image will be formed? When you place the object in front of the lens, when you place the object in front of the lens, what will happen? Rays from the object will refracted from the lens and we will get the image. As we have done in case of reflection also, what we have done, we have taken a mirror, like you can say concave mirror, and we have placed the object in front of the mirror and we will get the image. Okay, so in this case also we will do the same thing. So first case is when you will place the object, number one, when object is between focus and pole, not pole, optical center. Okay, so see this, this point is the optical center and here somewhere will be the focus. Suppose this is the focus, this is the focus, and now we are placing the object here. This is the object, this is the object we are placing, and we want the image of this object. Earlier also we have done this, the image formation of the object, but earlier the reflection is taking place. Here the reflection will take place. So what will happen? A ray of light like this, means a ray of light will be like this from this object, first ray of light, and this is parallel to principal axis. So I have told you this will pass from the focus. This will pass from the focus. So this point will be focus, and this is another focus. This is, you can say, the principal focus, and this is another focus. I have told you there are two focus, two foci in a lens, and another ray of light from this object will be like this. This ray of light is passing from the optical center like this. And now what we have to do, we will just in actual what will happen, these both rays will never meet. These rays are getting diverged. So in real, this ray and this ray will never meet. But what we will do for the image formation, we will produce these rays in the backward direction, and somewhere here in the backward direction these rays will meet and we will get the image. So this is the image we have got. And this is the object. And see here, see once again, a ray of light from this object is parallel to this principal axis. And I have told you, when a ray of light is parallel to this principal axis, it will pass from the focus. Okay, that is fine. And I have also told you, for the formation of image, at least two rays must meet or appear to meet. So second ray from this object will passing from the optical center, and I have told you, when a ray of light is passing from the optical center, it will remain undeviated, so it will go like this. But in reality, these both the rays will never meet. both the rays will never meet. So what we have done for the image formation, we have just produced both the rays in the backward direction and we got the image. Okay. So O for object, this is object, and I for image, and this O, you can change this O as right C. Okay. This is object. So I for image. So now from here you can see that rays are not actually meeting. Rays are not actually meeting. So this image will be virtual image. This image will be virtual image, and this image is erect also. You can see here this image is erect. So when you will talk about the nature of image, so you will say virtual and erect. And when you will talk about the size of image, then you can see this is the size of object, this is the size of the image, means the image is larger in size. So you will say larger than object, larger than object. And when you will talk about the position of image, so you can see here the image is formed behind the object. The image is formed behind the object and on the same side of the object. You can write on the same side of object and behind it. So these are the things that you have to identify. Just copy this. Azaan, are you getting? Yes. So these things we have already done in the mirrors. Formation of image we have already done. Azaan, please send me the test answer of the test. Okay, by tomorrow. Okay. And here is the object and here is the image. Just make the diagram properly. can write here. These rays appear to meet, and here you can write rays never meet in actual. Azaan, after noting this, you can leave the class. Okay. So nature of the image is virtual. Why virtual? Because rays are not meeting actually. And why erect? Because the object is like this and the image is like this. Size, you can see the size. The object is smaller than the image. Position, see here the image is forming behind the object and on the same side of the object. Okay, noted, Azan? Yes. Okay, Azan, now you can leave the class and we will meet in the next class. Okay. Okay.